This is a new chapter. This is chapter number 7. It's about study of gas laws. This is the first part. Now, you're going to see about different laws that rule the properties of gases. Now, talking about gases, the properties of gases depend on three different quantities. The first quantity is temperature, the second one is pressure, and the third one is volume. Three different quantities. First quantity is called temperature, second one is pressure, and the third one is volume. Talking about temperature. Now temperature is either measured, these are the units which we are talking about, either measured in degrees Celsius or it is measured in K, which is Kelvin. This is degrees Celsius. So that's in Celsius, and K stands for Kelvin. So two units which are used for measuring temperature. Now, if the temperature is given in degrees Celsius and if you have to change it to Kelvin, then what do you do? Or if the temperature is given in Kelvin and if you have to change it to degrees Celsius, then what is the procedure? That's what you're going to see next. So, if the temperature is given in degrees Celsius and if you have to change it to Kelvin, so to convert a degrees Celsius to Kelvin, all that you have to do is whatever is given in degrees Celsius, how much ever value is given in Celsius, with that you add 273 more. That will give you the value in Kelvin. So to convert degrees Celsius to Kelvin, I've given you an example. Say the temperature is 30 degrees Celsius. In Celsius, it is 30 degrees. If this has to be changed to Kelvin, then to this 30 degrees, which is in Celsius, add 273. So 30 plus 273. This will give the temperature in Kelvin. So if you add both of them, you will get 303. Now the unit has changed. It become Kelvin. Originally it was in Celsius. That was 30 degrees. You added 273. Now the temperature is in Kelvin. That's 303 Kelvin. So 30 degrees Celsius is 303 Kelvin. So whatever the temperature may be in degrees Celsius, you add 273 to that. That will change it to Kelvin. Now the other way, to convert Kelvin to degrees Celsius, the opposite, Kelvin to degrees Celsius. If you have to change Celsius to Kelvin, you add 273. If you have to change Kelvin to Celsius, then you subtract 273. So to convert Kelvin to degrees Celsius, an example, 293 Kelvin is the temperature given in Kelvin scale. So I'm going to change that to Celsius. So 293 Kelvin, that is what is here. From that you subtract 273. So if you subtract these two, you will get 20. So subtracting these two gives you 20, but now the temperature is measured in degrees Celsius. You change Kelvin to degrees Celsius by subtracting 273. So these two conversions you have to know, changing degrees Celsius to Kelvin and Kelvin to degrees Celsius. If you have to change degrees Celsius to Kelvin, you add 273. If you have to change Kelvin to Celsius, then you subtract 273. Those are about the units of temperature. And then I said there are three quantities. The second quantity is pressure. Pressure is measured in three different units. The first unit is centimeters of mercury. Hg stands for mercury. So it's in centimeters of mercury, or it is measured in millimeters of mercury, either centimeter or millimeter, but both with respect to mercury. And the third unit is atmospheres, or in short atmos. So these are the three units that are used for measuring pressure. Now, there is a relationship between all three of them. One atmos is equal to 76 centimeters of mercury or 760 millimeters of mercury. If you take 1 atmos pressure, which means it is also equal to, in centimeter, it will be 76 centimeter of mercury, and if it is in millimeter, it will be 760 millimeters of mercury. So that's one relationship that you have to know. Okay. If you have to change from one unit to another, okay, this you have to know. So that's about pressure, the second quantity. The third quantity is about volume. Third one is volume. Volume is the capacity, how much you can store inside this classroom. Okay, how much air can be filled. Okay, that's the capacity of this classroom. That is the volume. Okay. So volume uses units which are liters. It can be measured in decimeter cube. dm stands for decimeter. Decimeter cube, or it is measured in centimeter cube. This centimeter cube is also written as cc, cubic centimeter. Centimeter cube, or it is also called cubic centimeter. Okay, cc means the same. Or it is measured in milliliters. Okay, it's measured in liters or decimeter cube or centimeter cube, both are same. Or it is measured in milliliters. Okay. Now, this and this are the same. Centimeter cube, if I say 20 centimeter cube, means it is 20 milliliter. Okay. Both these quantities are same. And both these quantities are also same. If I say 2 liters, means it is 2 decimeter cube. Okay. So these two quantities are same. These two quantities are also same. Okay. So the relationship between them is, if you take 1 liter of anything, 1 liter is equal to 1 decimeter cube. 1 liter is same as 1 decimeter cube, and 1 liter is also equal to 1000 centimeter cube, and 1 liter is also equal to 1000 milliliter. As I said, this and this are same. You can see 1000 centimeter cube is 1000 ml. Okay. And I said this and this are same. 1 liter means 1 decimeter cube. Okay. So 1 liter is the same as 1 decimeter cube, and this 1 decimeter cube is same as 1000 centimeter cube, or it is same as 1000 milliliter. Okay. So these are the three quantities and the units that are used. Okay. Next, coming to gas laws. The first gas law is called Boyle's law. Now what does Boyle's law state is, temperature remaining constant, we are going to take the temperature to be a fixed value. Okay. We are not going to alter the temperature. Say the temperature in this room now is 20 degrees Celsius. So I am going to keep the temperature throughout at 20 degrees Celsius. Okay. So temperature remaining constant, we are going to keep the temperature constant. The volume of a given mass of dry gas, okay, we are going to take a gas. The volume of this gas is inversely proportional to its pressure. Okay. The volume of this gas is inversely proportional to its pressure. Means, if volume increases, pressure will decrease. If volume decreases, pressure will increase. That is what is called inversely proportional. If one quantity increases, the other quantity decreases. If one quantity decreases, the other quantity increases. So, inversely proportional. Means, there are two quantities here, volume and pressure. If volume increases, the arrow I put upwards means it is increasing. Then pressure will decrease. And if volume decreases, pressure will increase. It's the opposite. If one increases, the other one decreases. If one decreases, the other one increases. Okay. This sort of a proportion is called inversely proportional. Okay. Keeping temperature constant. Okay. Keeping temperature constant. Now, this is the relationship that you get from Boyle's law. Okay. That is, if the volume increases, then the pressure will decrease. Okay. So that's why the pressure is in the denominator. If one increases, the other one should decrease. Okay. So this proportionality where the other quantity is in the denominator is called inversely proportional. So volume is inversely proportional to pressure. If this was up, then it would be directly proportional. So in this case, volume is inversely proportional to pressure. Okay. Or if I remove this proportionality sign, if I remove this proportionality sign and put an equal to sign, then on this side I have to introduce a constant. The constant I am going to introduce is K. Okay. So V, this changes to equal to, if I change this to equal to, I have to introduce a constant into 1 by P. So this is same, only thing is this has changed to equal to. If you put equal to, then you have to put a constant. Okay. So if I bring the P this side, then P will get multiplied with V. So PV is equal to, there is nothing left here, there is a constant. PV is a constant. That is, if you multiply pressure with volume, it will always give you a constant value. Okay. This constant will be same whatever pressure and whatever volume you take at different conditions. Okay. Say in this room the pressure is P1 and the volume is V1. If you multiply that, you will get a value. Okay. Some number you will get. I go to a different place where the pressure is slightly different and the volume is also different. If I multiply P and V in that place, it will still give you the same constant. Okay. Now, this is what you get from Boyle's law. P into V is always a constant. Therefore, Boyle's law equation is two places, different pressure, different volume I am going to take. Okay. In the first place, pressure is P1, volume is V1. In the second place, pressure is P2, volume is V2. If I multiply in the first place, pressure into volume, P1 into V1. And for the second place, I multiply P2 and V2. These two values will be same. That is why it is equal to a constant. K is a constant. So P1 V1 is equal to P2 V2 is Boyle's equation. Okay. Now using this equation, you are going to solve a few questions. I'll give you an example. A certain mass of chlorine gas occupies 750 centimeter cube at a certain pressure. When the pressure was changed to 2.5 atmospheres, it occupied 1500 centimeter cube. What was the initial pressure if the temperature was kept constant during the complete operation? If you read the last part, it says, what was the initial pressure if the temperature was kept constant? Temperature is going to be kept constant. Okay. So in Boyle's law, temperature always remains constant. It's only dependent on pressure and volume. Okay. Let's go to this. A certain mass of chlorine occupies 750 centimeter cube. Okay. Now look at this unit. It occupies 750 centimeter cube. Centimeter cube is the measurement of volume. Okay. So this is the volume. 750 centimeter cube is the volume at a certain pressure. Okay. So you don't know at what pressure. This is the volume that is given and you don't know what is the pressure because it says at a certain pressure. Now, when the pressure was changed to 2.5 atmospheres, or in other words 2.5 atmos, pressure is changed. Originally you didn't know the pressure. Now in the second case, the pressure is changed to 2.5 atmos. Then it occupied 1500 centimeter cube. It occupied 1500 centimeter cube, means this is the volume it occupies. If this is the pressure, this is the volume. question is, what was the initial pressure? So you will have to consider two cases here. One is the initial values and second one are the final values. Initially, the gas occupied 750 centimeter cube, which means V1, initial V1 is 750 centimeter cube at a certain pressure, which means initially you don't know the pressure. P1 is a question mark, you don't know. Okay. Then when the pressure was changed to 2.5 atmospheres, finally when the pressure P2 is changed to 2.5 atmospheres, it occupied 1500 centimeter cube. Means the volume in the second case is 1500 centimeter cube. So these are the quantities that are involved. V1 P1, V2 P2. Temperature is constant, it says. So if temperature is constant, you will have to use Boyle's equation. So according to Boyle's equation, this is Boyle's equation. P1 V1 is equal to P2 V2. Substitute the values. P1 you don't know, into V1 is 750 is equal to P2 is 2.5 into V2 is 1500. Keep the P1 on the left hand side, shift the 750 that side. I have changed this 2.5 as 25 by 10 into 1500 and the 750 goes down, so into 750 here. Okay. To simplify this, both these can be divided by 750 two times. 2 and 10 goes 5 times. 5 and 25 5 times. Nothing left except the 5. So P1 is equal to 5. Look at this. We are finding pressure P1. So P1 is what we are going to find. Check P2. P2 was given in what unit? It was given in atmos. Therefore P1 also must be in atmos. So P1 is 5 atmos. Therefore, initial pressure is 5 atmos. That's what was asked, initial pressure. Next, a certain mass of gas occupied 850 ml at a pressure of 760 millimeters of mercury. On increasing the pressure, it was found that the volume of the gas was 75% of its initial value. Assuming constant temperature, find the final pressure of the gas. Assuming constant temperature, temperature is going to be constant. So if temperature is going to be constant, the quantities which are going to be involved here are only pressure and volume. Let's read. Certain mass of gas occupied 850 ml. Occupied 850 ml. 850 is the volume. So again, you take two cases, initial, final. 850 ml is volume 1. V1 is 850 ml at a pressure of 760 millimeters of mercury. So pressure 1 is 760 millimeters of mercury. On increasing the pressure, it was found that the volume of the gas was 75% of its initial value. Okay. The volume of the gas was 75% of its initial value. Initial value was this. Okay. So the final volume, that is V2, is, it says it was 75% of its initial value. Now 75% is 75 divided by 100. This percentage, it means 75 divided by 100. Okay. So 75 divided by 100 of its initial value. Of means multiplication. Initial value is 850. So this was in ml, so I have written ml here. Okay. Again, volume 2, about volume 2. On increasing the pressure, it was found that the volume of the gas was 75% of its initial value. Volume of the gas is 75%, means 75 by 100, of means into its initial value. Initial value was 850. It says on increasing the pressure, so which means to what the pressure was increased was not known, so P2 is a question mark, you don't know. This is what you're going to find. Okay. So these are the values that you know, V1, P1 and V2, P2 is what you're going to find. Temperature was constant, therefore you will be using Boyle's equation. So according to Boyle's equation, P1 V1 is equal to P2 V2. P1 is 760 into V1 is 850 is equal to P2, you don't know, into V2's value is 75 by 100 into 850. Okay. You can simplify this on both sides, or you can take all the values together. Okay. P2 is not known. Okay. So 760 is here, 850 is here. The 100 which is in the denominator on the other side comes this side, goes to the numerator, and divided by 75 and 850 goes to the denominator. Okay. Is equal to P2 is what is left on the right side. Now to simplify, you can cancel the 850. This and this can be divided by 25. I will go 4 times, I will go 3 times. So multiply 760 into 4 and divided by 3. That will give you 1013.33. You are finding pressure. Pressure originally was measured in what unit? You have to see. Pressure originally was measured in millimeters of mercury, which means this is also in millimeters of mercury. So 1013.33 millimeters of mercury is the final pressure. Final pressure is 1013.33 millimeters of mercury.